Well, we have seen polar and non-polar. So whenever covalent compounds make sharing, uh, the sharing may be polar, um, so covalent bonding sharing. It can be polar, or it can be non-polar. In the other polar. In the other way, it's the same as to say sharing polarity caused by unequal sharing, and non-polarity of molecule is by equal sharing. If you are going to evaluate equal sharing, we can give one example for each. For the first one, we can have an equal sharing, one element hydrogen with chlorine. Whenever two atoms placed in a periodic table at different corner, that place by itself indicates they have different electronegativity. Because in the periodic table, in the previous chapter, as you go across the periodic table, the electronegativity increases. So hydrogen has got this symbol and chlorine has got this symbol, which means partial positive and partial negative. Whenever we say partial positive means the bond formation is equal, the bond formation is through sharing, but the sharing is unequal. So this is displayed. The plus and minus indicates there is polarity. And when it comes to equal sharing, most of the time there are elements like carbon and hydrogen. Most of they have got similar electronegativity. And another stuff is between oxygen atom and oxygen atom, nitrogen atom and nitrogen atom, and so on. Chlorine with chlorine. These are examples of equal sharing. So they are said to be non-polar. If the electronegativity gaps is extremely big, big gap in electronegativity leads in forming ionic compounds. So most of the time this ionic compound is happening or taking place between metal and non-metal. So to make it easier, consider this one. In the case of ionic compound, we have metal sodium and non-metal chlorine. So the reason ionic bond is formed because at the end of the day, when the two atoms come together, they form sodium atom ion and chloride ion. What is happening? Electron is transferred from sodium electron in the outermost shell, and there is chlorine. Chlorine has got 7 electrons in the outermost shell, 2, 4, 5, 6, 7. So the transfer of electron from sodium transfer, don't forget this is transfer. The transfer of electron from sodium to chlorine brings about sodium ion and chloride ion. As a result, sodium atom reacts with chlorine. This indicates sodium chloride. This is purely ionic compound because sodium transfer its one outermost electron towards chlorine has got already 7 electrons in the outermost shell, 1, 2, 3, 4, 5, 6, and 7. Now there should be an agreement between sodium and the chlorine. What is the agreement? We can have electrostatic attraction if one, which means the metal part, delivers its electron delivers its electron towards chlorine, so that sodium become this atom and chlorine become 1, 2, 3, 4, 5, 6, 7, 8. Then it's noted by this one. Now this difference, electrostatic difference, which is positive and negative, make a strong bond, sodium chloride. We call this strong electrostatic attraction of electron. This strong electrostatic attraction of electron causes this molecule to have ionic compounds. So let's see the next move, how ionic compounds are. Okay, let's see in this video that a covalent bond, it forms a sharing, formed by sharing electron. And as you can see, we have an atomic structure, carbon, having 4 electrons in the outermost shell. So this outermost shell is now waiting for another sharing with an atom, so that look now, CH4, carbon is going to make a bond with 4 hydrogen, and in such a way it secures its valence electron 8. This is sharing. Similarly, if you see an ionic bond, together by the atom, sodium and chlorine, as you can see the atomic structure, sodium in the outermost shell, it has 1 electron over here, and chlorine in the outermost shell have got 7 electrons. Look, now the electron is transferred from sodium to chlorine, so that this transfer of electron make sodium plus to have 1 charge. Plus charge means plus 1 means loss of 1 electron, and chlorine gains 1 electron. This indicates gain of electron. Now both of them are now charged. Sodium is positively charged and chlorine is negatively charged. So this electrostatic force of attraction make a strong bond between sodium and chlorine.